There are a few other dynamic memory functions available besides malloc and free. I'm going to show them to you now. Well, I'm going to show a few of them to you. There are quite a few scattered around the Standard C library function. I'm going to show you the only true common ones that are available. There's a function called calloc. For the life of me, I don't know what the C stands for in calloc. Anyway, the only difference between it and malloc, well, there's two differences. One is that the memory that you get back is guaranteed to be initialized to all zeros. Okay, so that's nice. And this time you actually have two parameters, not one parameter, which is the size of the memory that you want, but two parameters. And the two parameters are how many things you want and how big each thing is. So obviously it's pretty simple. Calloc just does a little multiply. Multiplies the count by the size to guess how much memory you actually require in total. So it looks like this. It works exactly the same way that malloc works. See the little comma there after the 25? If you replaced that comma with a multiply sign, and you replaced the C in calloc with an M for malloc, then that would be the malloc that we used in the previous example. The only difference would be that this memory gets initialized to 0, but the malloc memory does not get initialized at all. So that's a handy function that you can call if you need the memory to be initialized. Now in the example that we saw with the reading 3 numbers in and printing them back out again, we did not need the memory to be initialized to zeros, because we went through and initialized all 3 integers ourselves by reading those values in from the keyboard. We did not need it to be initialized. So malloc would have been the better function to call then, because it would have been slightly faster. There's another function called realloc, which means reallocate. And it takes an existing area of memory that's got something in it that's been, say, created using malloc or calloc or any of the other dynamic memory allocation routines, and it simply changes the size of it, like so. You specify the memory address that you are about to modify. You pass that in as one of the parameters. You also pass in the new size, and it will give you back a pointer to the new area of memory. Now, it's important to note that the new address will often be different from the original address. It may be that the memory allocation routines have to go off and find a completely different chunk of memory that's big enough to hold the new size. If it does choose a different area and the new size is, say, bigger than the old size, then all the memory from the old one will be copied into the new one. And if new size happens to be smaller, then only the first new size number of bytes will be copied from the old one to the new one. So in other words, it'll behave sensibly as you would expect it to behave. Finally, we've got a function called strudup. This is a string function. String duplicate. That's what strudup stands for, string duplicate. It takes one parameter, a string, and it does the following. It allocates an area of memory exactly large enough to hold the string. So if the string is the word hello, hello is 5 letters plus 1 for a null. In other words, it will allocate 6 characters of memory, 6 bytes. And then it will copy the original string into the new string. It looks like this. Str2 would be a pointer, just like PTR was a pointer. Just like anything that you get back from malloc or calloc, it's just a memory address. So str2 will be a pointer to a character. It will not be an array. Str1, well, that'll probably be an array, or it could be another pointer. You'll find that quite easy to use when you get there. And this is all strudup does. It just does exactly that. So it's a little shorthand. It does a malloc of the length of the string plus 1 extra character for the null, and passes that back to str2, and then it copies everything from str1 into str2. You could write strudup yourself. It's a very, very simple function. But it's quite handy. It's quite handy to do that. It's a lot simpler than writing those 2 lines of code. Anyway, I'm not going to show you examples of those because they are, all 3 of them, quite simple. Just know about them and come back and look at these 2 slides if you ever need to figure out how they work again. I might set an exercise about using, say, one of those 3 in the exercises at the end of the chapter. Let's go and have a look at those now.